Hey guys, welcome back to chapter 12. In this video, we're going to talk a little bit more about entropy from a qualitative perspective, so just in the absence of numbers. And we're going to talk about some things that affect entropy, so what makes something more entropic or more messy, less entropic, less messy. So we're going to look at three properties that affect entropy. These are the three that we look at for now. There's certainly going to be more as you get deeper into chemistry, but this will be a good kind of introduction. So we're going to look at how molecular size affects entropy, how rigidity of structure, and then how temperature. So first, molecular size. The larger the molecule, the more motion, internal motion we're going to see. So particles, even if they are solid, they do have some sort of motion. They can vibrate or oscillate in place. So here's our vibrating back and forth. Well, this is like the whole molecule vibrating back and forth. This is kind of spinning in motion, and then vibration would be like the atoms coming closer together and further apart, so shortening the bond, lengthening the bond. So all three of these happen in any solid structure, liquid and gas as well. But the larger the molecule, the more internal motion that you're going to see. So if you think about like here, just a small little molecule rotating in place, as opposed to maybe something that's like up here on the screen, down here on the screen, and that rotates in place. So the longer that bond length is, the more motion you're going to see. And then same thing over here with vibration, like a short bond would be like little small vibrations. If this was a longer bond, like out to the edge of the screen, you could see how it would come in and out with greater force there. So how does molecular size affect it? Think about the more freedom particles have to move, the more they're going to disorganize themselves, right? So kind of a silly analogy that I use here is like you get a new puppy, right? And you go to leave that puppy at home for the first time. Are you going to let that puppy just kind of roam all around your house? That would be the greatest freedom of motion that puppy could have, and he's probably going to make an absolute mess. So what do? You limit the motion of that puppy. You limit where they can go. So you put them inside of a kennel, right? So much less motion, much smaller area they can move, a lot less damage is going to be done. So that's just kind of a silly analogy of like the greater the molecular size, the more space that molecule has to move in, and the more disorganized it's going to get. Properties, another property that affects actually this is still in size, I'm sorry. This is still with size, so we talked about just like the size of the molecule. Now we can talk about not just those bond sizes, but the size of a molecule as a whole. So here we've got, again, kind of our organic molecules. All of them are carbon and hydrogen bonds. But what we got here is one carbon surrounded by hydrogens. Here we have 2, 3, and 4. So as the structure gets bigger, we see that the entropy also goes up as well. So it's not just talking about like within a bond of an atom, it's talking about the molecule as a whole as well. So the bigger the molecule, the bigger the size, the more motion, the larger the entropy is going to be. The next one is rigidity of structure. So more rigid equals less motion. So here we've got two molecules. You've seen these already. So diamond and graphite. So diamond and graphite are similar in that they are solids and that they are made up of just carbon atoms that are stacked together. But if we were to dive into and look at how those carbon atoms come together, there's much more rigidity in the structure of a diamond and a little bit less rigidity, more opportunity for motion in graphite. So the more rigid, less motion, higher the entropy. And then vice versa, the less rigid that structure is, the more motion it's going to have, and the more entropy it's going to have. And then lastly, a property that affects entropy is temperature. So as we increase the temperature, we increase the kinetic energy. So we increase the motion of those particles. So the faster that they're moving around, the more dispersed, the more of the mess they're going to make. And then we also see that increasing the temperature also very often leads to state changes, which we know gas to liquid to solid, or excuse me, solid to liquid to gas, also increases the entropy as well. So just three things to look at as you're starting to, maybe look at the numbers and like, does that make sense? We can start to think about the size of the particle. Is it bigger? Is it smaller? We can start to think about the rigidity of the structure. What does that structure look like? And then we can start to think about, well, what happens if we heat it up? What happens if we cool it down? How would that affect the entropy? So just a quick qualitative look at some properties that affect entropy. I hope you found this helpful.